Hello and welcome back to StudyMonster's OCR GCSE Computer Science video series. Today we're going to build on our Boolean logic video and look at logic diagrams. So, quick reminder then about the logic gates that you're going to need to be aware of for your exam. We've got the AND gate. So the AND gate has two inputs and one output. Now, both inputs have to be positive in order to get a positive output. The OR gate is very similar. We've got two inputs and one output. The only difference is that at least one of the inputs must be positive in order to achieve a positive output. And finally, we've got the NOT gate that is one input and one output, and this will flip whatever the input is. So if we get a positive input, we will get a negative output. So let's look at a simple example of a logic diagram. So we've just got one gate in this one. So let's imagine that we've got a secure lab somewhere with a secure door. We cannot access that lab, the room, until we use the staff member's key card and scan it in. And we also enter a correct pin on the keypad. Both of them need to be true in order to access this room. So if we take a look at what the diagram would look like for this one, we've got a basic AND gate. So we've got two inputs, A being the staff member's card and B being the pin code. So both have to be correct in order to gain access to the room. And then we've got the expressions that go along with this diagram. So Q is accessing the door opens, equals A and B, or we've got Q equals A and B with a caret symbol. And finally, the truth table that we've seen in our last video, our two input columns A and B with our different inputs, followed by our output column showing the results of them inputs. Right, a more complex diagram this time round. So multi-gate diagram, so we've got three gates in this one. So imagine you're trying to listen to music during break, but your headphones are smart headphones and they only let you play music under certain conditions. So it's a little bit of a far-fetched example, but let's just go with it. So your headphones will only play music if your music app is open on your phone and your headphones are connected via Bluetooth, but not if you were in lesson time, so if you're in a classroom environment. So let's take a look at what the diagram would look like for this one. So we've got the AND gate, so our A, so the music app is open, and your headphones are collected would be our input B, so they're going into an AND gate. And not in lesson time would be our C input, which is a NOT gate. And both of these need to be combined with an AND. So you've got to have your music app open, you've got to have your headphones connected, and you've got to not be in lesson. And if we look at the expression for this logic gate, we've got Q equals A and B. So a bit like in BidMaths, if you were given that expression, you would evaluate what's in the brackets first. So your A and B would go at the beginning of the logic diagram, and not C. Or Q equals A and B in brackets using the caret symbol, and not C as a second expression variation. And if we look at the truth table is going to be a lot bigger because we've got three gates involved here, and we're going to look at a little bit of a hint on the next slide as to how you would calculate how many rows you need for a truth table based on how many gates there is on a logic diagram. This is a question that has popped up in the past and it could pop up again. So working out how many rows you need for a truth table based on a logic diagram. So every input, you've got to remember, every input in a logic circuit can only have two possible values. So it's 0 or a 1. So you're off, and you're false, or you're on, you're true. The rule is the number of rows is 2 to the power of n, where n is the number of inputs that we've got. So if we think of a circuit with only one input, like a NOT gate, it's going to be 2 to the power of 1, so that is 2 rows. If we look at a circuit with two inputs, like an AND gate, it's going to be 2 to the power of 2, which is 4 rows. And you should start seeing a pattern. If your circuit has 3 inputs, like a multi-gate example, 2 to the power of 3 is equals 3 rows. So you need to remember that each new input, doubles the number of rows. So 1 input, 2 rows, 2 input, 4 rows, 3, 8, 4, 16, and so on and so forth. I haven't seen an example so far with anything more than 3 gates, but it might ask you to calculate how many for a given expression, as an example. So when you see a circuit diagram, you should count the inputs and then double for each one. So that's it for logic diagrams. Please like and subscribe for some more videos, and I will see you in the next one.